Hello student, very good morning to all of you. I hope you all are happy, healthy and fine at home. So what did we discuss yesterday? We discussed yesterday about the hydrogenation, means formation of alkane. And hydrogenation, what type of the reaction it is, what are the reagent used for the hydrogenation reaction, what is the role of catalyst, what it will do, or what we can call it as how the mechanism takes place, whether it is a exothermic reaction or endothermic reaction. These types of questions answer we are obtained from our previous lecture, so that we already got. So what we are going to discuss today, today we are going to discuss about ozonolysis, formation of aldehydes and the ketones. So ozonolysis, the question always appear on this point, what is ozonolysis? So what is ozonolysis? Discuss the ozonolysis with suitable example, and let me tell you something about that ozonolysis. What is ozonolysis means, what is the definition of the ozonolysis? And ozonolysis, it is a process of breaking down the carbon-carbon double bond, is known as ozonolysis, and it is a classical method for breaking the carbon-carbon double bond. Before what we can call it as before the spectroscopic technique available, the chemists are using one of the for structure determination. This is the test the scientists using for the determination of the organic compounds. So as we know that ozone molecule, have you heard about this ozone molecule? And this ozone molecule, oxygen molecule, we know that. Now you might be knowing, here suppose this is called as a oxygen atom, this is called as a O2 molecule, and this is called as O3, means it is known as a ozone. This O3 is known as a ozone. And if you talk about little bit about this ozone molecule, the ozone molecule, it is present in the stratosphere. As we know that atmosphere means what? Atmosphere, envelope of air around the earth is known as the atmosphere. There are the four regions are there. Which are those? One is called as a from near the earth, it is known as a troposphere, and second is known as a stratosphere. Third one is called as a mesosphere, and last one is called as a thermosphere. So these are the region according now on their kilometer they are divided. We are not going to go into detail of that, but here little bit about that ozone molecule. It is playing role just like as a blanket we are wearing during the winter season. Now is the winter season is going to start from the next month. Now is October is going on. So to protect from the cold, we wearing the blanket, and we are getting as a sound sleep, right? And same due to the ozone layer which is present in the stratosphere, a thin layer in the stratosphere, it protect whole the earth. Because whatever the cosmic rays or the hot rays, it get trapped by this ozone molecule, and we are alive or we are living happily. All the organism living very happily on the earth. If now due to the industrialization or civilization or the population is increasing day by day, and due to this reason some refrigerators are there, curtains are there, so a lot of when they get damaged for refrigerant, one gas is used as, I think, chlorofluorocarbon, which is highly harmful to the ozone molecule, and when that get one free radical of that chlorine atom can destroy 1 lakh molecule of the ozone molecule, and due to that reason, so in some in ozone there will be a hole generated or created, and due to that the harmful rays is coming directly on that earth, and they causing the skin cancer, and that are the this is little bit about that ozone molecule. And now let us come to the chemist point of view. Ozone molecule is a very good for as per as a chemist point of view. Remember, it is a cleavage, it is a process of cleavage of carbon-carbon double bond completely, and the molecule we are getting as a smaller molecule in case of that aldehyde and the ketone. As we know that the general formulas of that aldehyde and the ketone, the common thing present in aldehyde and the ketone are the carbonyl group, and as we know that carbonyl group is a very reactive due to that electrophilic addition reaction or nucleophilic addition reaction takes place over there. The aldehyde RC double bond OH, and the ketone has a general formula RC double bond O R dash. That are the aldehyde and the ketone. The definition of aldehyde and the ketone: the organic compound having a general formula RC double bond OH is known as a aldehyde. This group is known as aldehyde, which is a characteristic of that aldehyde. And now ketone, this is a carbonyl group present over there. On both sides there will be a alkyl group or maybe as a aryl group depending upon the nature of that R. So that is a ketone. The general definition of ketone: the organic compound containing or having the general formula RC double bond R is known as a ketone, where R and R dash may be as a alkyl or the aryl group. So that is there. But here we are talking about the what is ozonolysis, means a definition you should remember. The process of breaking down the carbon-carbon double bond is known as a ozonolysis, and we are getting as a fragmentation of the molecule, smaller molecule we are getting, and this is a classical method for the determination of the structure of the organic compound. And let us see that ozone molecule, that O3 molecule, this got a O3 means ozone molecule. Ozone molecule, how it is a resonating structure of ozone molecule, how it get reacted, that we will see first. First let us see as a general reaction of ozonolysis. Suppose we have this as usual we are taking as a example CH3, then CH double bond CH2, and that will be treated with first one is a ozone molecule, second one is a zinc in presence of water. Zinc is a zinc dust we are generally referring over here. Now zinc in presence of water, what does it give? It gives the product here like this CH3, then H I am writing purposely here C double, because it is a classical method to break the carbon-carbon double bond. Look at, there is a carbon, it does not break as a single bond, remember, it breaks the carbon-carbon double bond. So if you observe the structure carefully, what do you see over here? There is a carbon-carbon double bond, it exactly going to break from the middle. One oxygen added across this and one added here, one already I am written over here, and another one, this is a carbon atom here, C double bond O, one CH2R I am writing here, one H here and another H over here. What I am putting one hydrogen, one oxygen atom here and there. So breaking at that carbon, instead that we are getting as a aldehyde and the ketone. Here both are the aldehydes. So one of the structure. This is called as acetaldehyde, right? Acetaldehyde, and this is known as a formaldehyde. This is known as a formaldehyde. These are the common name of this compound. Can you tell me the IUPAC name of this compound? Right, you know that the IUPAC, full form of IUPAC, International Union of Pure and Applied Chemistry. According to that, there are 2 carbon atoms are there, and carbonyl group aldehyde is there. Last suffix for aldehyde is used as a Al. Remember, Al means aldehyde group. Which group? Aldehyde formyl group, C double bond OH group. And for OL, this indicate as a alcoholic group, hydroxy group, OH group. Remember, most of the students get confused in between OL and Al. Al means carbonyl group, aldehyde group, and aldehyde, always remember, aldehyde group is always present at the end of the carbon chain. Remember that one. And alcoholic OH, OL means alcoholic. Suppose it's a ONE, ONE indicate as a ketone group, C double bond O, this group. Ketone groups are there, ONE. That are the last suffix word. So according to that, what is that? There is a ethane, so we can call it as a ethane, and last E get replaced by Al, ethanol. Ethanol. So that is the IUPAC name of this compound. I am showing in a bracket, that is IUPAC name. And there is only one methane is there. So methane slash E you should replace by Al. You will get the IUPAC name now of that compound that is there. So methanol, right? Methanol, Al. Last suffix is Al. Here also as a Al. So this is the IUPAC name. These are the common names are there. Sometimes common name is famous than the IUPAC name, depending upon that structure or how frequently the organic chemists are using. But internationally followed system we can use over here. So this is the simplest one what we have. Now let us look at as a mechanism of this. How the mechanism takes place over here. Here let us see as a mechanism, how the mechanism is carried out, or how we can show the mechanism here. In a ozonolysis, just now we have seen O3 molecule. First let us see the resonating structure of O3 molecule. How we can write as a O3 molecule, we can write like this. Here is a negative charge, here is a positive charge, the oxygen having as a lone pair, as we know that, right? This is a ozone molecule, resonating structure of ozone. Resonance structures. Resonance structure, are you can call it as a canonical structure, right? And as we know, you apply all the root, and that resonating structure is shown by the double-headed arrow. I am showing double-headed arrow here. Now this negative charge forming double bond, and that negative charge goes on that other side of the, there is a oxygen atom 1, 2 and 3, that is a V-shape structure it is. Now there you are going to get here, then this side O minus, then now is a double bond. Still the middle oxygen atom has a 3 bond, and therefore positive charge still remains on the oxygen atom. Then we can show another structure over here. This double bond, we can neutralize this positive charge, so that we will get the structure like this. This structure, oxygen atom, and this oxygen atom, what we did, here is a minus charge, it get neutralized. Now when these bonds shifted from here to here, so what is going to happen here should be the positive charge, or you can reverse of it. So oxygen atom, oxygen and O, we can put here positive charge, and on this oxygen you can put as a negative charge, middle having as a lone pair. So these are the resonating structure of ozone molecule. This is a 1,3 dipolar compound. This is known as a 1,3 dipolar compound. 1,3 means what? There is a 1, 2 and 3. 1, 2 and 3 atoms are there. Therefore, it is called a 1,3 dipolar compound. Dipolar molecule. This is 1,3 dipolar molecule. Now when 1,3 dipolar molecules are there, now how it attacking over there? Let us see here. CH3, then CH, double bond, CH2, then this or that species, let us see here, O, oxygen, and here oxygen atom. Now here is a, suppose is a minor charge, here is a positive charge over there. Now what is going to happen? The negative, this the lone pair, not lone pair, the pi bond is going to attack on that oxygen atom which carrying as a positive charge, and the negative charge is going to attack on this carbon atom. Remember, these are the arrow. How I am showing this arrow, that is the mechanism of this. Now when is here you are going to get C, then here hydrogen atom, single bond, CH2, and this O, and look at this type of the 5-membered ring is formed. This is a unstable species. That species is known as monozoolide. This is known as a monozoolide species, which is unstable in nature. Now this unstable species trying to break this double bond is now going to break over here. This double bond is going to form as a double bond over here, and then this is going to break over here, and this lone pair forming as a double bond here. Look at this, how I am showing as arrow. I am breaking the bond between this carbon atom and this carbon atom, forming as a double bond with this oxygen atom. At the same time, this bond, the bond is breaking between this oxygen atom and this oxygen atom. Now the lone pair which is present on that oxygen atom forming as a double bond with that oxygen and the carbon. How do I get? I am going to get over here. Look at here, CH3, then CH. Here is a double bond O, and there is a O minus charge. Now this middle bond is broken. In this case, I am cleaning this board now, and now this C double bond, for sake of mechanism, I am writing like this, CH2, right? And then C double bond O, I am writing in this manner. And now after that, what is going to happen? This negative charge. Now look at this oxygen atom. There is a positive charge on this oxygen atom, because this oxygen atom has a 3 bond, 1, 2 and 3, and therefore now this negative charge is going to attack on this carbonyl carbon, and this double bond is going to attack on this carbon atom, and this bond, double bond, is neutralizing this positive charge. What do I get over here? Now this compound looks like this, CH3, then CH, here is a oxygen atom, here also has a oxygen atom, then this middle bond is not there, and now here CH2 and one oxygen coming exactly on the opposite, exactly above one, right? Look at here how this is getting here the structure, and this species is known as a ozonolide. Ozonolide, and this species is a ozonolide, and this ozonolide get trapped with the zinc. We are using as a zinc as a dust over there. That is a reducing reagent we are using over there, zinc. So you can write as a Zn over here in presence of the water. What is going to happen now here? Now this bond is breaking, forming as a double bond here, and this bond forming as a double bond here, and this oxygen atom goes with that zinc oxide, and metal always carries as a positive charge. And what do you get here? If you write here, you will get here this one CH3, then you can write here is this hydrogen atom over there, double bond O, and plus this oxygen atom O double bond C, and there, as you know that this hydrogen atom you can write like this. This is the mechanism of ozonolysis. Understood this one? This is the simplest example of that ozonolysis, and we are getting as a formaldehyde and the what we can call it as acetaldehyde. So this is all about. Now let us look at as a application of it. Application means what? Example of this. Let us see how and as we know that it is one of the classical method for the determination of the position of the carbon-carbon double bond, right? Now let us see how it is used, where it is used for the structure determination. Now I am writing here is one of the example. Suppose just now we have seen we have this one CH3, then suppose here CH2, then CH double bond CH2, that is treated with first one O3, second one zinc in presence of the water. You try to predict the product because you are knowing as a when you can predict the product when we are knowing the mechanism. We already know the mechanism just now. Now you can able to predict the product. So now let us look at as another example over here CH3, then CH double bond CH and the CH3 like this. And third example I am the same reagent. First one is the ozonolysis, second one will be the zinc in presence of the water. Third one I am taking over here CH3, then here CH3 double bond, then CH3. Now here I am taking first one O3, second one will be this one Zn in presence of H2O. Now fourth one, let us see here CH3, then CH3 double bond here CH3 CH3, then another methyl group, and then taking as a first one ozonolysis, second one will be the zinc in presence of H2. I am purposely taking as a different so that you can understood how the Asian scientists using this as a chemical test for the determination of the unknown compound, right? So if you treat this compound, so you are going to get the product CH3, then CH2, then CH, or here you can write C double bond O H, and then here formaldehyde H, C double bond O H, formaldehyde. One product, if there is a monosubstitutes are there, one we are if remember here, if the carbon-carbon double bond is present at the terminal one of the product is a formaldehyde, that clearly indicate that the carbon-carbon double bond present in the unknown compound is at the end of the chain. So that type of the conclusion they are drawing at the time of the where there is a no spectroscopic technique available at that time. Now we can very easily find out the structure of the organic compound with the help of different modern techniques such as IR, UV, NMR, carbon 13 NMR, mass spectroscopy. So these are the different techniques. By using this, by combining of this technique together, we will get the correct structure of the organic compound, and that, what is that? UV, NMR, so or IR, what type of the information they are providing us. UV gives the carbon-carbon double bond, whether they are in a conjugation or in isolated form, that type of the information, only the monochromatic light are used over there. And then second one, IR, there are the different functional groups are in the present in the organic compound, and by knowing their knowing their frequency, IR frequencies are there. So different functional group providing different frequencies, and from that we can very easily, by analyzing their spectra, we can easily come to know that what type of the functional group are present in the known compound, and NMR provide the very good relationship about the protons or their hydrogen, and number of type of the proton, number of the NMR signals are obtaining. And so in that way, and that type of the study at this T.Y.B.Sc in your fourth term, we are going to learn in detail of that. So here just remember as a ozonolysis. Now I am breaking the bond here, you are going to get as a 2 molecule of this C double bond, or 2 molecule of acetaldehyde, that clearly indicate that this olefin is a disubstituted one. 2 acetaldehyde molecule clearly indicate. If if you break this, what do you get? In this case, you are going to get CS3, C double bond O, CS3, and plus another side is this one, CS3, C double bond O, H. One is acetone and another one is a formaldehyde, acetaldehyde. That clearly indicate that olefin is a tri-substituted here. Look at here, I am breaking from here. This side is acetone, this side is a acetaldehyde, but I am writing as this separately. Now when I am breaking from middle one, ozonolysis, same the reagent. What do I get? I get as a 2 molecule of acetone, CS3, C double bond O, CS3, right? So that clearly indicate that our starting compound is a tetra substituted. Suppose there is a ring is present like this. Let us see here. Suppose you have this type of the compound present over there. Because first one O3, in second one will be Zn in presence of H2. What do you get? The ring get glued from here. So this type of the diol CHO, then this one CHO. 1 to diol means 2 is there. Al means aldehyde group. So that type of the compound. Suppose this is another one. Suppose you have another ring like this. In this case, suppose here is a methyl group CS3, and the same reagent you are performing, same reagent you are using in this reaction. So what do you get over here? In this case also, first one is the ozonolysis O3, second will be the Zn in presence of water H2O. And what do you get? This bond is going to break on that side. So here CS3, here double bond oxygen. You are going to get, let me ring get open, and another end you will get as a aldehyde group, ketone and the aldehyde. So by knowing what type of the product they are getting, from that they easily understood what type of the olefin are present in that reaction. I think with this we have completed all the reaction, whatever reaction for your syllabus we covered here for carbon-carbon double bond. Let us see here collectively all those reactions. So in this case, so carbon-carbon double bond, I think all this collective reaction we will see in the next lecture. Let us stop today here. Have a nice day. Thank you.